So cubic functions, or should I say cubic functions, since we're using functions as a word rather than a polynomial or something, we say cubic functions. Now, cubic function is that function, the f of x, where the highest degree of the polynomial is 3. So that's why we call it cubic. There are a couple of cubic forms that we need to know. The one that I've just written here, ax cubed plus bx squared plus cx plus d, this is called a general form of cubic equation. Then there is another form which is ax minus h cubed plus k. This is called, I shouldn't say the turning point, I should say the stationary point form. Stationary point form, where h comma k is your stationary point. In the world of cubic, the stationary point, especially when you have something like this, is the point of inflection. What is point of inflection? That is the point of inflection. In this scenario, 0, 0, and I've drawn a graph for y equals to x cubed. This is my point of inflection. What is point of inflection? From my grade 11 days, my point of inflection, and if you remember a bit of a calculus, and if I change the color of my pen, my point of inflection tells me that my gradient is positive as I'm coming from negative infinity. At this point, the gradient value is 0, or the derivative is 0, if you remember that. Gradient at a point on the curve is derivative. And then it does not change its sign and it keeps going positive. So if you see this kind of a behavior in your stationary point, that stationary point is called the point of inflection. Is this clear, everyone? Just sort of, dusting your, knowledge from grade 11 off. Is this clear? I need to hear a
Yeah.
yes, right? Everyone, yes, Ikra.
Yeah.
Good. Ashkeet, yes.
Yep.
Cool. All right. Now, this is point of inflection. Then I'll change the color of my pen. And then the third form is called the intercept form. Intercept form. Intercept form is a x minus x1, x minus x2, x minus x3. So in this scenario, the x1, the x2, and the x3 are my x-intercepts. And if I were to draw cubic, this is x1, this is x2, this is x3, provided my x1 is less than x2 is less than x3. So there are 3 forms that I can use for cubic functions or polynomials, if we were to use that term. General form, stationary point form, and point of intercept, the x-intercept. Should say x-intercept. This is the x-intercept, not the y-intercept. Now, A here in first form, in the second form, and the third form is the dilation factor. It tells me how much broad or how much narrow my graph is going to be. The mouth of my graph is going to be. A is the dilation factor. Now, another few things on cubic, important points. If I were to draw a cubic will be of a few different types. One, two, three, and four. Since it is a cubic function, at the max, cubic function means it is having a degree 3, x cube. So the maximum stationary points will be 2, which is that if this degree is n, so n minus 1. Always remember that. If it was a quadratic, my degree was 2. For a quadratic, my degree is 2. And how many turning points quadratic has? 2 minus 1. It's only 1, the parabola. Just one turning point. I should call stationary point. So max, you can have less than that, but you cannot have more than that. So if you look at graph number 1, coming back to cubics, it has got just one stationary point here, which is the point of inflection as a POI, the point of inflection. Similarly here, point of inflection. Whereas graph number 3 and graph number 4 have turning points as stationary points. So this is TP, TP, TP1, TP2, turning point 1, and turning point TP1 and TP2. Now, when you have these two, 1 and 2, they are exactly the same. The only difference is that 2 is a reflection of 1. So this is a reflection of 1 and vice versa. In number 2, my A value, not the A value will be a negative value. You'll have a negative in the leading coefficient, the x cube. The coefficient of x cube is negative always. And that tells you that you are drawing a reflected cubic. Whereas in A, in first graph, you'll have A to be a positive value. See, A in itself is dilation factor. It's not negative or positive, but algebraically speaking, you will see a positive and a negative sitting with the A, right? A itself has no positivity or negativity. A just defines the dilation. But just to remember that, you see a negative and a positive in front of the leading coefficient. And A happens to be the coefficient of the leading term as well. And the dilation, depending upon obviously which form you're using. So 1 and 2 are the point of inflection form reflected. And if I just change the color of my pen, here the graph will be f of x equals to ax minus h cube plus k. Here you will see y or f of x equals to negative ax minus h cube plus k. Something like that. Coming back to 3 and 4. Cubic in general always have their arms of the graph in the opposite direction, first and third quadrant, if your cubic is not reflected. So graph number 1 and graph number 3, you see first and third quadrant. So whenever you see the arms of your cubic in first and third quadrant, it is a non-reflected cubic. Whereas when you see the graph of your cubic's arms in the second and the fourth quadrant, here and here, in 2 and 4, this is reflected cubic. This is a reflection. Now, for graph number 3 and graph number 4 can have any one of these forms, can use any one of the two forms here, which is either a general form or a intercept form, right? Which is ax minus x1, x minus x2, x minus. So that's in a nutshell what a cubic function is, how they look, how they behave when they're reflected, and what are their general forms. Is this sort of making sense? Yes or no so far?
Yep.
Yeah.
Cool. All right. Now, what we are going to do is we are going to see when, if we were asked to find, if we are asked to find the rule of a cubic, which form to use when. So I have three forms. F of x equals to ax cubed plus bx plus square plus cx plus d. You will use this form when you are given 4 points on the graph. Why? Because you are after finding 4 unknowns. So for your question in the exam will give you 4 different coordinates on the graph so that you can sub them in and find A, B, C, D. So if you have that kind of information provided to you, you can use this form. Now, next one. The next form is if I am given something like, if I have f of x equals to ax minus h q plus k. When can I use the turning point or stationary point form? Whenever I am given the point of inflection plus one more point. If this kind of an information is given to me, then I will use the point of inflection form to find the rule. And the last but not the least is the x-intercept form. So whenever I am given the x-intercepts, straight away, and one more point, then I can use the third rule, the third equation, intercept equation, to find the rule of my cubic. Now, you can argue that the x-intercepts are nothing, but they are just the coordinates, right? They're just the coordinates on the graph. So if I assume them to be coordinates, that means I'm given 3 coordinates plus 1 as another point. I'm given 4 points. Why should I not use the first one? You can. You can use the first or the third depending upon what kind of the coordinates are being provided to you. If the coordinates are random coordinates, then you have to use, you should use, and you can only use the first form. But if those coordinates happen to be the x-intercepts and you need all 3 of them and one random point, then in order to save time, you should use the third equation and not the first equation, though you can use the first equation as well, because eventually the x coordinates as in the x-intercepts are still the coordinates. So based on the information that is provided to you in the question, you should be using one of these 3 forms to find the rule of your cubic. Is this clear, everyone? And we are now going to jump on to questions. Is this clear?